Hi and welcome to the old doghouse workshop. Today I'm going to fit a Powerfeed to my Warco Major GH milling machine. This machine is an all gear driven machine. It's not the most expensive on the market, nor is it the cheapest. But having had this machine for 3 months, I only started to use it 2 months ago. But the only real drawback to it is that the rear column that supports the milling head is a bit on the small side, I think, for doing the job it's got to do. To all intents and purposes, it might as well be made of rubber. I can flex it by up to 0.06 of a millimetre, that's 2 1/4 thou at the height it's currently set. 2 thou might not sound a great deal, but when you're trying to get a nice finish on a face, it's nigh on impossible. My workshop is an all wood affair. It's wood construction externally and internally, but in between it has a large amount of insulation, not just on the walls, but on the floor and in the roof. The whole construction is laid on a bed of concrete and concrete lintels to make it as strong as possible. Heating is provided by electricity or by a wood stove. I'm currently using this milling machine as a manual X and Y feed. It's a large table, 28 3/4 by 8 1/4. That's 730mm by 210. And at 730mm long, your arm gets a bit tired winding the hand wheel, and I couldn't wait for my Powerfeed to turn up. It's 2 days before Christmas and the Powerfeed finally arrives. The suppliers had a problem with sourcing a power reduction unit. That's a transformer to you and me. Having unpacked it, I laid it out to confirm all the parts are there. There was no packing list of any kind, so I had to assume that with what I've got laid out in front of me was it. The booklet, entitled Powerfeed Operation Manual, was written by an Oriental person assisted by a pigeon to translate it. For instance, it has an anti-vandal switch. I interpret that as being the rapid Travis button. On page 2 it's got pictures that appear to have been randomly drawn down from the internet to explain various safety features, headed with the title Warning. Now to get on with the task in hand. On the right hand side of the table, the hand wheel engages and disengages by sliding the hand wheel into and out of the dog drive. On the left hand side, the wheel is always engaged and can't be disengaged. I am, however, wondering how I'm going to lubricate this oiler point when the whole thing is assembled. The assembly instruction within the manual is nothing more than a picture showing roughly how things look, giving dashed lines and arrows to guide you to where the things should be when they're finally assembled. Some of the descriptions: small adapter, fair enough, but big adapter, okay, anti-vandal switch, comical. Another page covers the limit switch assembly, along with a few spelling mistakes. The power unit itself requires 110 volts AC, that's to make it work properly. The outside of this transformer box is an American style socket, accepting the plug from the power unit to provide the power. The power input to this box is 230 volts, 220, 230, 240 AC. This voltage is used in a large part of the world, but the wiring input is for the UK or Europe. I'll crop these wires down to a suitable size to be able to put them into a UK style plug top. On the bottom of the transformer box there are a couple of keyholes and 2 round holes to attach the box to a wall. The keyhole openings are approximately 8mm in diameter, that's about 5/16, and to mount the box I used a few number 4 countersunk wood screws. Removing the lid reveals a transformer and a bit of spaghetti. Taped to the lid is a spare fuse. Laying the lid down exposes a problem with stressing some of the wires. Transformer is loose on first inspection, and there's a fuse block mounted below the transformer and beside the output socket. I'm taking the warning lamp off the cover while I mount the unit to the wall. It should prevent distressing any of the wires. I decided to mount this unit on the wall and then firm up all the internal screws later. But as I sat the unit on the wall screws, I heard something rattle through the back. And it was one of the transformer's mounting screws. Obviously, the person assembling the unit was using a powered screwdriver. Naturally, that person didn't tell the line foreman about the problem, probably through fear of loss of pay perhaps, and elected to just simply close the lid and call it a good one. To retain the transformer, I've had to use a larger self-tapping screw to replace the one that had fallen out, as I suspected the threads were completely stripped out. The most worrying thing of all was that all the electrical wires were loose, and even worse than that is that the earth cable wasn't even connected at all. So I went round everything in the box and nipped everything up to ensure that my life wasn't in danger when the power was finally switched on. I've just noticed here that the earth cable is a bit too close to the live 110 volt output wire. I'll just move these away to prevent any further problems. I'm a subscriber to Pete 22, or Tubalcane as he's better known, and amongst some of his general observations he's a little less than complimentary about Eastern manufacturing quality. I can sort of understand exactly where he's coming from. Well, as I see it, this small adapter goes onto the end of the table, the left hand side, and is tightened by these two bolts. Then the big adapter, their phrase not mine, sits on these two bolts and is fastened here, supporting the main power unit. The main power unit drives this gear that is fastened to this end of the main feed screw, using an Allen key to lock it into place. These bolts require a 12mm spanner or wrench to tighten them up. I'm placing this small adapter equally centred across the width of the table. I've got no clue as to whether you're supposed to or not, but here goes. I'm also being quite cautious about over tightening these two bolts because I've seen the results on YouTube of someone doing just that and had to make a new bracket after having split the casting. I think this big adapter is not quite up to the job of supporting the weight of the power motor. It's only holding the power motor on with two very small 6mm bolts and right at one end, so the immense amount of weight hanging off, well, I can see it breaking off. And this is what I mean, is two small 6mm screws holding this motor onto this plate. Having mounted the small adapter onto the end of the table equally from each side of the table, I have found that the big adapter that has been fixed to the power unit places the power unit off centre to the lead screw and fowls up against the lead screw gear and one side to the inside of the arc of the main power assembly body. It's plain to see that this power unit has been adapted to sit on the end of the table horizontally, but the casting obviously shows that it was designed to hang vertically below the table. The print on the controls clearly indicates this. I'm going to offset the small adapter by 4mm. That's about what I think it needs. That's done the trick. The gears are to be covered using this plastic cover. There's two sticky pads that are used to hold it into place. So I just have to wipe the surfaces and then stick it on. The next task is to fit the limit switch and the associated wiring. This is a relatively simple task compared to fitting the actual motor itself. First, remove the original table stop and clean up around where the wires are going to be placed. Now to bolt on the limit switch mounting block, followed by the limit switch itself. We used the original stop screws to mount the limit switch onto the block, but the problem is that the two slideways that they'll sit in are a bit too wide and they could possibly pull through, so they need a couple of washers making. The old stops are quite small and need to be swapped out and replaced with longer pieces. However, this wasn't without its own problems. The old stops are held in place by a mysterious force, and this force turned out to be a long reach grub screw. The other problem was that the little dovetail pieces that fit down the locks were too big, so had to be filed off in order to get them to fit. The cable from the limit switch was going to be another problem, insofar as that when the table was traversed in on the y-axis and out again, the cable could potentially catch on the dovetail slides. To support the cable, I didn't want to make holes for clips, etc., so I've opted to use cable ties supported from several 20mm square plastic clips. They're held on with double-sided sticky pads. I'm not sure how strong they are, but I hope they will last for a while before having to be replaced. Now the moment of truth. Will it work or won't it? I'll just put in. It's about to turn the power on. We'll see how things go. Switching it on. A little green light has appeared on the rapid traverse button, or around the rapid traverse button. If I remember rightly, they called that the anti-vandalism switch or anti-vandal switch. That's it, job done, and it's functioning as well as I'd expect it. However, at rapid traverse I wouldn't have it rapid traverse up to the limit switch. I fear that the time it takes to power down would literally run it off the end and damage the switch. Here is the old hand wheel and the hand wheel screws, the old stop plate, and of course the stop buttons. The equipment I used was obviously the manual. The Allen keys were 2.5mm, 5mm and 6mm. A rule, some tie wraps. I used a few blocks, screwdrivers, a 12mm spanner, wire strippers, wire clippers, spirit level to put a level pencil mark for the box on the wall, some grips, an electric screwdriver and a few wipers. That's about all you really need. Could do with some instructions on how to do the job though. Something a bit easier than the actual manual. Apart from that, that's all. Click on thumbs up if you liked or enjoyed the video. Pass on any comments and I'll be only too pleased to answer them. Once again, thanks for watching. Bye.